Hello everyone, welcome back. Today we'll be discussing application and differentiation and we'll be treating gradients, also known as slope at a given point. The concept of differentiation is the same as that of the gradient or slope. So when we say the gradient or slope of a function at a point, we are only referring to the differentiation of that function and substituting for the s value given or among the points given. Other concepts required in this subtopic will be shown as we go on. Our very first example to explain this concept further is from 2004. It states that the gradient of the curve y equals to 3s squared plus 11s plus 7 at the point P with coordinates s and y is minus 1. Find the coordinates of P. The first thing we are going to do is write down our equation y equals to 3s squared plus 11 plus 7, and differentiating our equation, the y over dx will be equal to 6s plus 11, which will also be equals to our gradient. So our gradient is 6s plus 11. But we are told that gradient is minus 1, thus the y over the s is equals to minus 1. Now substituting minus 1 for the y over the s, 6s plus 11 will be equals to minus 1 and 6s will be equals to minus 12. Simplifying further, s will be equals to minus 2. To get the y coordinate, we substitute s equals to minus 2 into the original equation. Doing so, y will be equals to 3 in bracket minus 2 square plus 11 in bracket minus 2 plus 7, which will be equals to 12 minus 22 plus 7, which is equals to minus 3. So the coordinates of the point P is minus 2 and minus 3, and the correct option is B. We have another example from UMA that states that find the slope of the curve y is equals to 2s squared plus 5s minus 3 at the coordinates 1 and 4, and we are given the option. Now the first thing we are going to do is write down our equation y equals to 2s squared plus 5s minus 3, and to get our slope, which is our dy over dx, we are going to differentiate the equation. Doing so, the y over the s will be equals to 4s plus 5, and at the points 1 and 4, s is equals to 1. Now the next thing is to substitute s equals to 1. Doing so, it becomes 4 in bracket 1 plus 5 equals to 9. Our next example states that find the gradient of the curve y is equals to 2 root s minus 1 divided by s at the point s is equals to 1. Now our first step is to write down our equation y is equals to 2 root s minus 1 over s, and simplifying is also the same as y is equals to 2s to the power of 1 over 2 minus s to the power of minus 1. Our next step is to find our derivative. The y over dx will be equals to differentiating 2s to the power of 1 over 2 is going to give us s to the power of minus 1 over 2. Then differentiating minus s to the power of minus 1 to be equals to plus s to the power of minus 2. So our dy over dx is equals to s to the power of minus 1 over 2 plus s to the power of minus 2. Now removing the indices and simplifying, it will be equals to 1 divided by root s plus 1 divided by s squared, which is our gradient. Now the point where s is equals to 1, we are going to be substituting 1 to be equals to 1 divided by root 1 plus 1 divided by 1 square, which is equals to 1 divided by 1 plus 1 divided by 1, which is equals to 2. The correct option is C. We have another example that states that at what point is the gradient of the curve s squared minus 6s plus 3 equal to 0? Now the first thing is going to be writing down our equation, that is f of s is equals to s squared minus 6s plus 3. Now we are going to be finding the gradient, which is also the derivative. Now f prime of s, which is our dy over the s, is equal to differentiating s squared minus 6s plus 3 is going to give us 2s minus 6. So when the gradient is equal to 0, we'll be substituting 0 for f prime of s, or for dy over the s, which is 2s minus 6 will be equals to 0. Simplifying further, bringing the 6 to the other side, become positive, so 2s will be equals to 6. Now dividing both sides by 2, s will be equals to 6 over 2 and s will be equals to 3. Our next example is from NECO, and it states that find the differential coefficient of the function y equals to 1 divided by s squared plus 9 at the point 4 and 1 over 25. Now the differential coefficient is the same as the y over the s or its derivative. Now differentiating our function, y equals to 1 divided by x squared plus 9 is the same as y equals to x squared plus 9 in bracket raised to the power of minus 1 from our law of indices. Now differentiating this using chain rule, let z be equals to x squared plus 9, thus y will be equals to z raised to the power of minus 1. Now the z over the s will be equals to 2s, and the y over the z will be equals to minus z raised to the power of minus 2. Now substituting for the z over the s and the y over the z in our formula, we state that the y over the s is equals to the y over the z times the z over the s. It will be equals to minus z to the power of minus 2 times 2s, which is equals to minus 2s divided by z to the power of 2. Now substituting for z equals to x squared plus 9, our equation becomes minus 2s divided by x squared plus 9 in bracket square. We are going to be putting s equals to 4 into our dy over dx result, which should be equals to minus 2 in bracket 4 divided by 4 squared plus 9 in bracket all squared, which should also be equals to minus 8 divided by 25 in bracket square. That is minus 8 divided by 625, and the correct option is A. Our next example states that the slope of the tangent to the curve y equals to 3x squared minus 2x plus 5 at the points 1 and 6 is. Now in our solution, we are going to be writing down our equation. Y is equals to 3x squared minus 2x plus 5, and our slope is the same as our derivative, and differentiating our equation, dy over dx will be equals to 6s minus 2. At the point 1 and 6, s is equals to 1. Now substituting s equals to 1, it becomes 6 in bracket 1 minus 2, which should be equals to 4. Our next question states that find the coordinates of the point at which the gradient of the curve y equals to s squared minus s plus 4 is 3. Now the very first thing is that we are going to be writing down our equation, y equals to s squared minus s plus 4. Now our gradient, which our derivative, will be equals to 2s minus 1. That's the y over the s equals to 2s minus 1, because when we differentiate s squared minus s plus 4, gives us 2s minus 1. And we are told that the gradient is equals to 3. Now we'll be substituting 3 for the y over the s in our equation. So 2s minus 1 will be equals to 3. And simplifying, 2s will therefore be equals to 3 plus 1, and 2s will be equals to 4. Dividing both sides by 2, s will be equals to 2. Now to get our coordinates, we are going to be substituting s equals to 2 into the original equation. Doing so, y will be equals to 2 squared minus 2 plus 4, which is equals to 4 minus 2 plus 4, which is equals to 6. So the coordinates at the point will be 2 and 6. Our final example is from PC in 1995. It states that find the points on the curve y is equals to s cubed plus 6s squared minus 15s plus 1 at which the gradient is 0. Now our very first step is to write down our equation, y equals to s cubed plus 6s squared minus 15s plus 1. Next, we are going to be finding the derivative, and when we differentiate, dy over the s will be equals to 3s squared plus 12s minus 15. At the point where the gradient equals to 0, dy over the s will be equals to 0. So now substituting dy over the s equals to 0 in our equation, it becomes 3s squared plus 12s minus 15 will be equals to 0. And the next step is to divide through by 3. Doing so, it becomes s squared plus 4s minus 5 equals to 0. As you can see, we have a quadratic equation, and our next step going forward is to factorize the equation. Factorizing, that's splitting our 4s into 5s and minus s, because those are the factor, because minus 5 times minus 1 will give you minus 5, and minus 5 plus 1 will give you 4. It becomes s squared plus 5s minus s minus 5 is equals to 0. Factorizing further, it becomes s into s plus 5 in bracket minus 1 into s plus 5 will be equals to 0. Factorizing again, it becomes s plus 5 in bracket s minus 1 is equals to 0. Therefore, s plus 5 will be equals to 0, or s minus 1 will be equals to 0. S value equals to 0, therefore S will be equals to minus 5, and when S minus 1 equals to 0, S will be equals to 1. That is, S will be equals to minus 5 or 1. Now using S value to find Y, when S equals to 1, Y will be equals to 1 cube plus 6 1 square plus 15 in bracket 1 plus 1, which is equals to minus 7. And the coordinates at that point will be 1 and minus 7. And when Y equals to minus 5, Y will be equals to minus 5 in bracket cube plus 6 in bracket minus 5 square minus 15 in bracket minus 5 plus 1, which will be equals to minus 125 plus 150 plus 75 plus 1, which is equals to 101. And our coordinate at that point will be minus 5 and 101. The correct option is A. We have some exercises for you to try your hands on at home. The answer to these questions are found in our Hidden Fact Further Mathematics textbook. You can get the hard copy, or if you are interested in a soft copy, you can get it at the website at the bottom of the screen. Thank you.